Electrolysis is a process by which electric current is passed through a substance to effect a chemical change. The chemical change is one in which the substance will lose or gain an electron. That is nothing but either it will undergo oxidation or reduction. And the process is being carried out in an electrolytic cell, which is nothing but an apparatus, and that apparatus will consist of positive and negative electrode. They will be held apart and it will be dipped into a solution that will be containing the positively and negatively charged ions. And in electrolysis, the substance to be transformed may form the electrode that may constitute the solution, or it could also be dissolved in the solution. Hence, the electric current, that is nothing but the electrons, will enter through the negatively charged electrode, which we call it as cathode, and components of the solution will travel to this electrode. It will combine with the electrons and it is being transformed, or we could say it is reduced. So the products formed in this process can be neutral element or it could be a new molecule. For example, if we consider this is the electrolytic cell or the apparatus. Here we take one as the cathode and the other as an anode, and we have the electrolyte solution. So if we see in elaborate, we take here two copper strips. They are dipped in an aqueous solution of the copper sulfate, and then a DC voltage is being applied to both the electrode, and copper ions will discharge at the cathode, that is Cu2 plus 2 electrons will give us Cu. Copper metal is being deposited on the cathode and copper is converted into Cu2 plus ions at the anode. The reaction is Cu will give us Cu2 plus 2 electrons. So here the impure copper is the anode, which will dissolve on passing current, whereas the pure copper will get deposited at the cathode, and metals like sodium, magnesium, aluminium, they all are being produced using electrochemical reduction of their respective cations. So based on the electrolysis, we have two Faraday's laws of electrolysis. The first law of Faraday's says that the amount of substance deposited or liberated at an electrode will be directly proportional to the quantity of electricity passed through the electrolyte. So in mathematical representation, if we give, it is Q is directly proportional to I into T. I is nothing but the current and T is the time in seconds, and if we rearrange that, we say it as M is equal to ZIT. Z is the constant, which we call it as electrochemical equivalent. And the second law of Faraday is when the same quantity of electricity is passed through solution of different electrolytes, the weight of different substances deposited or liberated at the respective electrodes are directly proportional to their chemical equivalent weight. So when we say equivalent weight of the metal will be equal to atomic mass of the metal by number of electrons required to reduce to cation to the metal. And in the process of electrolysis, when we talk about the products of electrolysis, the product of electrolysis produced will totally depend upon the nature of the material being used or that is being electrolyzed and the type of electrodes that is being used. So the electrolysis will produce products which is present in the compound. Hence, when more than one cation and anions are present, each ion will compete for reduction and oxidation, and according to that the product will be produced. But there are certain factors which affects the process of electrolysis. The factors that may affect the process of electrolysis are the nature of the electrode. It could also be the nature and state of the electrolyte. Nature and electrode potential of ions which is present in the electrolyte may also affect the process of electrolysis, or if we are applying, or if there is an over voltage at the electrode, that may also impact the process of electrolysis. Hence, there are certain factors which is going to affect the process of electrolysis. Hence, that should be kept in mind when the process of electrolysis is taking place. So, the conclusion from this is the two Faraday's law, first law and the second law, is very, very important as far as the chapter electrochemistry is concerned. Hence, it is very important to know the laws of Faraday's. That is, two laws we have for Faraday.